All right, this is, again, heavy on the algebra. Again, in terms of solving systems. This will be a repeat of a lesson that it's actually a repeat of like 3 or 4 lessons that you did in Algebra 2, kind of all combined into one day. But you've already seen all this, none of this is new. All right, a system. What is a system? A system's a bracket which includes 2 or more equations. So the equations might be something like this: x squared plus 4x minus y equals 7. And 2x minus y equals -1. This is a 2-equation system. There could be multiple of these. Okay? So this happens to be a 2-equation system. The solution are variables, values that work in both equations, not just in one of them, but values that work in both equations at the same time. So an x and a y combination that would work in both of those systems. So we're going to do 3 ways that you could solve that system, different systems. And so in Algebra 2, you would have done maybe 1 method a day. Today we're going to do all 3, but you've seen them all before, and I think you'll remember most of them. Okay, so the first method is one actually we've been practicing already. It's the method of substitution. And so the method of substitution requires you to pick a variable to get a loan. It doesn't matter which one you pick, you just make a choice the variable you think looks to you like you could get it a loan the most easily. So substitution method, pick a variable to isolate or to get a loan. All right, so let's look at the problem that we just had. What would you pick to get a loan in that equation? It can come from the top equation, it can come from the bottom equation, it doesn't matter, you just have to make a choice. Which y? There's 2 y's. You could pick the y on the top or the y on the bottom, it does not matter. All right, so I heard some of you say, let's pick the y on the bottom. All right, so if that's true, okay, that's fine. So we'll take 2x minus y equals -1. And what would you do to get that y by itself? You'd subtract 2x, okay? So that would give me -y equals -1, subtract 2x, but y is still not alone. So then what? Divide by -1, all right? So everything would get divided by -1, so y would become positive, 1 is positive, and 2x is positive. So the substitution method starts that way, pick a variable to get a loan, and then you're going to take that variable that you had alone and plug it back in to the other equation where that variable was also positioned. Make sure you plug it back into the opposite equation. So we are going to take this value right now and plug it back into the other equation, which was the top one, into the position for where y is. But be careful, what's right in front of that y? A negative sign. So you're going to have to, when you make your substitution back in, you're going to want to use parentheses. So that'll be x squared plus 4x minus, and then parentheses will come the 1 plus 2x is what you're substituting in. And that's equal to 7. The reason I do that and I use parentheses is because that reminds me that I have to do what next step? Distribute. And what should we be distributing? The negative sign. Okay, so we'll distribute that negative sign. That would be x squared plus 4x, and then -1 minus 2x equals 7. So this is a problem that has a square in it. And going all the way back to the beginning of the year, the strategy for every squared problem is to set one side equal to 0. Okay, so we want to take care of that 7 and make sure that we get this equal to 0. So I'm going to subtract 7 from both sides. And I'm going to take the like terms. Where do you see like terms? 4x and -2x. All right, so this will combine into x squared. The like terms would be positive, excuse me, 2x. And then the subtraction of the 7 would give me -8, and now that would be equal to 0. And the good thing is when you have a square equal to 0, you have a couple methods that you could use. You could go back to the quadratic formula if you want, okay? Or you can try to factor using one of our 3 factoring methods. So you have the choice at this point. So just like at the beginning, you had the choice to choose what variable you wanted to get alone. Now you have the choice of what method you want to use. So you could use the quadratic formula, will always work on a squared problem, or you could try split factoring or star factoring or GCF factoring. So I probably would go to star factors. I'd look at the -8 and the 2, and I figure I could come up with 4 and -2. And so then I would do split factoring with the 4 and the -2. And I'd split that down the center. Take out what they have in common, which is x and x plus 4. Take out a -2, leave me with positive x plus 4. It's still equal to 0. And so x plus 4 is the common factor, and x minus 2, and that's still equal to 0. And if it's still equal to 0, then they're each equal to 0 by themselves. Because the product of two things that equals 0 means one or both of them has to be 0. So x is -4, and the other x is positive 2. That's not the end of the problem, though. So I don't just need to solve for x. What else do I need to solve for? Y. And we'd gotten y alone back at the beginning anyway. We know that y by itself was 1 plus 2x, which means y should be 1 plus 2 times -4. And y is also going to be 1 plus 2 times 2. So I have multiple solutions for x and multiple solutions for y. So y is -7 this time, and y is positive 5. Now you have to write your answer in pairs. Don't just list it like this, where you've got 2 x's listed and 2 y's listed. You want to pair them together. And so the solutions are -4 was the first x, and -7 was the first y. So those two get paired together. And 2 was the second x, and 5 was the second y, and those two get paired together. So they're written as pairs. And what do those pairs remind you of? Points. Points where? Points on a graph. Okay, so what does that mean? That means if you drew this system out, they would cross each other 2 times. And that's the second method, is the method of graphing, where you would see these two things crossing each other. We are going to do that. All right, any questions on method number 1? All right, method number 2. So that leads us right into the graphing method. In the substitution method, you could pick any variable to get alone. In the graphing method, you have to get both y's alone, because the only way you can graph something is with y equals in the calculator. So the graphing method requires you to get both y values alone. So I asked you to get your graphing calculator out. I'll have mine out and at the ready. Couple things. Could you please make sure your graphing calculator, that the y equals are all cleared out, that there's nothing in there from other problems that we did? And could you make sure your window is set to standard values of -10 to +10 for the mins and maxes with a scale of 1? So if we can all be on the right standard window, that'll help us in our solving. Okay, so your standard window, mins are -10, maxes are +10, the scales are all 1. That'll also work. All right, our first graphing example is the system, so the brackets of 3x plus 2y equals 6 compared to y equals ln x minus 2. In this problem, one of the y's is alone, but the other one isn't. So one of them is fine, but our job is to get both y's alone. So the y2 is fine the way it is. ln of x minus 2 is just fine. But in the top equation, I'm going to have to get my y alone. So what should I do? How do I get that y alone? Subtract 3x followed by what? Dividing everything by 2. All right, the result of that, when you've subtracted 3x and you've divided everything by 2, is 6 minus 3x over 2. Okay, that's the answer. So the graphing method then would have us put this into our graphing calculator and see how many times these intersect each other. So I'm going to switch screens. If you can go ahead and type those into y1 and y2, and we'll take a look at what those look like. Oh, I'm sorry. I did in my notes and I forgot to on this the slide. Okay. Thanks. Yeah, everything, every part. So 6 was divided by 2 also. Yeah. All right, so 3 minus 3x over 2 is y1, and then the ln of x minus 2 is under y2. So hopefully you know what 3 minus 3x over 2 is just going to be a line with the slope of 3 over 2. ln, you remember those are the lazy logs. The lazy logs come straight up and then they just sort of level off. Logs get level because they're lazy. So we'll take a look at these two equations. So we can see the line that comes down with a negative slope, and we can see part of the lazy log. All right. I don't know if your calculator shows you all of it, but there is more. It just gets, I don't know why my calculator is getting cut off. So they cross each other one time. So what do I want to see in your homework in terms of an answer for this? Okay. Well, I want to see this sketch. It does not have to be perfect. You don't even have to make scale marks. Okay, I just want to see that you know that it goes down like this and that they intersect and kind of get the intersection in the, it doesn't have to be on graph paper. I just need to see a picture of what you saw when you looked at the graph. Okay, it does not need to be on graph paper. It does not even need to be on Notability. I just need a picture. Okay? All right, now we need to find the intersection. Do you remember how to do that?
Second trace.
Second trace. So second trace gives you the option of the intersection, which is option number 5. Use your left and right hand arrows to hover over the spot where the intersection is. Okay, it's asking you if the first curve is in the right position where you want it to be, you hit enter for yes. It's asking you if the second curve is in the position of where you want it to be, you hit yes. It'll ask you a third time, is that a good guess? And you hit yes. And then it tells you, hey, I want 3 decimal places rounded. All right, so your homework would look like this. All right, you got your grid there. I just want to see that you saw the line that came down like this. And I want to see the intersection. I'd like it to be in the right quadrant, please, at least. Get the intersection in the correct quadrant. Okay, that the intersection is right there. And then you can use an arrow or something to point to that, and you can tell me that the intersections of that was 2.484, comma, negative 0.726. Okay, that's all I need to see. So I want to see the work you did to get your y's by itself. I would like to see the a sketch of the graph, and then like an arrow pointing to the intersection spot. All right, let's try another graphing one, because not all graphing ones come out as nicely as that. All right, so our second equation for graphing is x squared plus y squared equals 4. Sorry. And the other one is 3x minus 2y equals 0. So neither of those are in the place where y is by itself yet. So we need to do a little bit of work on getting y alone. Okay, so top equation. What should I do to get y by itself? Let's talk through that. subtract x squared, okay? So just maybe on some scratch work here, it would be like y squared equals 4 minus x squared. And then how would you get that, continue to get y by itself? Okay? Square root, but what goes in front of every cotton pick and square root we've done all year? Okay? Plus or minus. So this is going to be y equals plus or minus the square root of 4 minus x squared. So when you type it into your calculator, that's going to fill in spots for y1 and y2. Okay, y1 is going to be the positive 4 minus x squared, and y2 is going to be the negative 4 minus x squared. Because your calculator doesn't have a plus or minus button, it needs you to separate the two into two separate things, which means we will need a y3 as well. Right, so getting our y3 by itself, that would be just getting, that's pretty easy, that's going to be a line, so we can subtract 3x to both sides and divide by -2, so we get 3x over 2. All right, so let's switch over and take a look at what these graphs are going to look like. That's -3x divided by -2, and the negatives reduce. Right, if I've got -2y equals -3x. Yeah, I subtracted 3x, so I divide by -2 and the two negatives. Okay, yeah, last time I did make a mistake, but this time I think I'm okay. All right, so we'll switch over, and we'll take a look at what we get this time. So the positive square root of 4 minus x squared over the negative square root of 4 minus x squared, and then the other one is just 3x over 2. Okay. All right, so we get a semicircle on the top and a semicircle on the bottom and a line that intersects through both of them. Okay? Not looking like that, Daniel? Okay, let's do our intersections. So you'll sketch that graph, right, on your paper. So you'll draw a picture of what you see so that you see the upper semicircle and a lower semicircle intersected by a line. Yeah, I will, but I'm going to keep it here. All right, so let's do our intersections. Second calc number 5. Okay, I want you to remember there's not just a first curve and a second curve. There's a first curve, second curve, and third curve this time. So up in the first quadrant, we'll follow the first curve and we'll hit enter because we're sitting right where we need to be. And then notice what the calculator does when you hit enter. It drops you down into quadrant 4. That's not where we want to be. And look at what curve it's on, up in y2 in the corner, right up here. Okay, we don't want to be on y2. We want to be on the line. And what number was the line in our calculator? Okay, it was y3. So the only way to get yourself to y3 is to use a down arrow. That frustrates people because they think, I want to go up. That's not the way up and down arrows work. Up and down arrows work you through the list of the equations that are in your y equals. It's the side to side arrows that move you left and right. So if you hit the down arrow, you will actually go up because it's changing the equation to the next one in the list. That's what the up and down arrows do. Don't get confused in thinking that the up and down arrows necessarily move you up and down on the graph. They're moving up and down on the list of equations that are in your graph. So if you want to change to a different equation, you got to use your up and down arrows. So then I'm in the right place. So I'll hit enter, and I'll come up with the first intersection, and I will label that on my graph that I'd drawn as 1.109, comma 1.664. Now we got to do the other one. So we'll start our second trace over again. Again, notice that it automatically puts me on y1 equation. I want to go to the y2 equation, which is down 1 on my list. And so I hit the down arrow, which drops me down to that equation, and then I'll use my left arrow to get myself into position. Then I'll hit enter, and then it will put me on y3. So it always does them in order. It'll go y1, y2, y3. If you want to skip around, you have to use your up and down arrows. And then I'll be fine in quadrant 3, and I'll have my last, my second intersection spot. All right, so on your paper now, you would have drawn a picture, and you would have both equations, or both intersection points labeled maybe with an arrow or two to show that that's intersecting. Okay, any questions on graphing? Okay, then we'll go to the last method. The last method is called elimination. And elimination is canceling out a variable completely. Kind of like Thanos. If you're a Avenger fan, snap your fingers. 1 out of every 2 people, 1 out of every 2 variables gone. Okay? All right, so this is the elimination method where we cancel out a variable completely. We'll do a couple examples of this. All right, this year we sold 261 tickets to JSB. Okay, you know the prices, right? VC students were 85, right? Okay, and guests cost 95. If total sales were 22,425, how many of each kind of ticket were sold? So you like how I snuck a little word problem in there? All right, well, what are the 2 types? Wake Daniel up back there. What are the 2 types? No, not the cost of the 2 types. What are the 2 types? Students and guests. Okay, those are the 2 types. Those represent your 2 variables. So you're always going to want to identify what 2 things there are in these problems. We'll get into 3 things in a future day, but we're going to stick with 2. So we've got X, and we'll call those VC tickets. And we've got Y, which are guest tickets. When you write your own equation for a system, there's always going to be an X plus Y option. All right, what does X plus Y equal in this situation? No, not 22,000. That's the dollar amount. That's not what we're talking about. These are just how many tickets there are. All right, this is equal to 261. Don't mix your unit metaphors, okay? Tickets added together equals a ticket quantity, not a dollar quantity. But then we'll talk about dollars. Okay, so the dollar amount would be 85 for the X's and 95 for the Y's, and then we have our total of 22,425. Okay, this is a system that's set up perfectly for the style of elimination. Elimination is cancel out a variable completely, and you can pick which variable you would like to cancel out. All right, so for example, if I picked X as the variable I would like to cancel out, then I need to take this top equation and multiply by negative 85. Why would I pick the number negative 85? because it's the opposite of positive 85, and I want to make this problem, the x's disappear. So I would have negative 85x and negative 85y and negative whatever 261 times 85 is. So I'm distributing negative 85 to all the parts of that system. All right, so you grab your calculator, which you still have out. You take 261 and you multiply it by negative 85, which is going to give you negative 22,185. Now we eliminate. So in the snap of our fingers, the x's are gone. How many y's am I left with? 10. 10 y's equal, and then you figure out what you're left with when you add 22, 425 on the other side, and you're left with 240. So if 10 times y is 240, what's y? 24. And what did y stand for? The guest tickets. So we sold 24 guest tickets. Okay? Does that fully answer the question? So the question is how many of each type were sold. And so we would need to figure out how much of the x's were. Well, we know that 261 was the total, so we can subtract 261 minus 24, which gives us 237 VC tickets. So that's a sample of elimination. Okay, here's another sample of a type of elimination question. Yeah, okay. Marcus, what you doing? What you watching? On our, Issa, do you have one too?
Yeah.
Okay. On one of our very first dates, my husband and I went to a movie, and he took me to one of those bulk candy shops, you know, where they sell everything by the pound. And he's like, let's get candy for the movie, right? And we weren't really thinking about how much of candy we were adding into this. I think we ended up with $37 worth of candy when we finally brought the thing up. We were a little excessive, all right? But that's going to set the stage for this next problem. It's a little too much poundage of candy. All right, here we go. Here's my favorite, Sour Patches. All right, Sour Patch, they are $4 a pound. Okay, his favorite are Lemon Heads. Okay, Lemon Heads are $5.25. It's never a good deal to go to one of these bulk places. It's always way more expensive. Just go to Walmart or whatever and buy it there. But anyway, such is how we ended up. Okay. Okay, you create a mixed bag. That weighs 3 pounds. And costs $4.73 a pound. How much of each type of candy is in there? Did you get? Okay, so how much of each candy type did you get? All right, well, again, all of your problems are going to be set up that there's 2 variables. You can keep using x and y if you want. You can use creative letters other than x and y if you like to use S for Sour Patch and L for Lemon Heads, whatever. Okay, but we're going to have x to equal our Sour Patch and y to equal our Lemon Heads. And you're going to start out creating your system with something that is x plus y. All right, so we want, it's not just the Sour Patch, but it's the Sour Patch weight and the lemon head weight. Okay, so how much does x plus y make together? Not 31. That's a 3, and that's an L. 3 pounds, that's an L. 3 pounds. All right, x plus y equals 3. Okay, there were 3 pounds mixed all together. Now we need to assign the dollar value so we can figure out a combination here. We know that the x's are $4, so that's 4x, that's the lemon heads. The Sour Patch was $5.25. Y. But be careful about what you put here at the end. Okay, think about the prom question, the JSB question. What we put there was the total amount of sales altogether. What I have not given you in the question yet is how much this bag cost. Okay, you need to figure out for yourself how much this bag costs. You know how much it weighs, and you know how much it costs per pound. If it weighs 3 pounds and it costs $4.73 per pound, you are going to have to yourself figure out the cost of the weight before you write it. So it's not just $4.73. That's a common mistake, is that people just put $4.73 there. That's not true. Okay, it's $4.73 per pound. All right, so Emma, did you get it? All right, what is it correctly? All right, so this one, $14.19. All right, now this problem is set up perfectly to eliminate, and so you can have the choice of which variable you would want to eliminate. To me, it looks like x would be the best option. So what would you multiply by so that x would eliminate well? Okay, I'd multiply by -4. So I'm going to take the top equation and I'm going to distribute -4 to all parts of that equation, which will give me -4x and -4y and -12. So I just distributed, and I have a new equation which I just wrote underneath. Okay, snap of my fingers, I eliminate x. The y's go from 525y minus 4y to 125y. And 1419 minus 12 is 219. Which should then tell me how much I could figure out for how much of the y, which is the lemon head weight. Okay, so 219 divided by 125. Okay, that's 1.752. What are the units on this? Pounds. Pounds of what? Pounds of what kind of candy? Okay, pounds of lemon heads. You have to be specific. You can't just say pounds because that doesn't tell me which type it is. Then we should be able to figure out how much x there is because we know the total is 3. And so we can subtract, and we're going to get 1.248 pounds of Sour Patch. Okay, I have one more slightly different equation, but still elimination. We'll decide of the 3 methods that we did, which method is going to be the best. So is substitution going to be the best? Would graphing be the best, or would elimination? And you can choose. So this is our final example of where you pick. A pane of glass has perimeter 120 inches, and area 864 square inches. What's the size or dimensions of the pane of glass? Okay, so what are the size, or I'll call them dimensions? Okay, well, if I'm trying to find dimensions, what 2 things am I trying to find? What do dimensions measure? We've got perimeter, we've got area. What two dimensions are we talking about? length and width. Okay, it's not a complicated question. So you need to assign which is which. You can use L and W if you want. You can use X and Y, but make sure you tell me which is which. Okay, X is length, Y is width, or whatever you want to do. You can use different letters if you want. All right, so we got to create an equation. How do we write that the perimeter turns out to be 120? What is the perimeter of something that's rectangular in shape? Say it again. Not just X plus Y. That's only, X plus Y is only this side and that side. That's not perimeter. How? Okay, it's X plus Y plus X plus Y. That's perimeter. Okay, the perimeter is 120. How do we do area? Okay, so X times Y. Okay, X times Y equals 864. So I'll clean this up a little bit. Emma was suggesting 2x plus 2y, so that's probably a little better way to write it. All right, 2x plus 2y. Okay, so now your choice. Of the methods that we did today, substitution, graphing, or elimination, you get to choose which way you want to do it. If you eliminate, I'm going to say elimination is probably off the table. Why? The x and y are multiplied, not added or subtracted. In order for elimination to work, it's got to be set up where you've got something plus something equals something for both of them. That's really the only way elimination is going to work. So elimination is not a good option. But you could choose to get a single variable alone, which would be substitution, or you could choose to get both variables alone, which would be graphing. It's really up to you what you want to choose. Does anybody have a favorite choice at this point? Graphing, okay? Okay, and that is fine. You will have to change your window though, because you'll come to me and be like, there's nothing on my graph. Okay, and I'll say that's because your window is still stuck at 10 and negative 10. So I'm going to say I would choose substitution. Okay, which variable do you want to get alone? The x where? The bottom x. All right, so KP says get the bottom x alone, so that would be 864 divided by y. All right, so we'll go to our equation and we'll put that x in. So that would be 2 parentheses 864 over y plus the 2y I already have equals 120. So when you multiply, that's 1,000, I think, 864 times 2. 1728 over y plus 2y equals 120. Okay, we have a y in the denominator we don't like. And when we have a y in the denominator we don't like, we should get rid of it by multiplying everything else by y. So we're going to take this whole problem and multiply it by the number y, or the letter y. So that will be distributing a y to this one, a y to that one, and a y to that one. That will give me plain 1728. What will it give me after the 2? Y squared. And what will it give me after the 120? 120 what? Y. And now that I have a problem with a square in it, what do I need to set that equal to? 0. So let's put this in the right order. 2y squared minus 120y plus 1728 equals 0. So what are your options now for solving something that has a square in it that's set equal to 0? You could do the quadratic formula, or you could factor. What do they all have in common? A 2. So I would take out the 2. Okay, they're all even, so that's what I would do. Take that out. And then again, you still would have to choose, do you want star factor or quadratic formula? It's up to you. Okay, yep, up to you.